systems where you had people coding all these rules, and that could be for the medical domain, could be for fixing a car, could be for handling a customer service complaint, whatever it is. People would code all these rules, and it was a real nightmare because you had to be a professional to know how to write the rules, and you had to have these highly trained knowledge engineers, and they had to talk to your domain experts and make sure they got things right, and then you had context and all the ambiguity issues I talked about. So it didn't work out. A lot of money was spent, a lot of promises made, and eventually the company just went out of business because they couldn't meet them. And things got a little more exciting in the 90s with Deep Blue. And Deep Blue is an example of reasoning, right? Because you're reasoning about how to play a chess game. It's also an example of learning. And a lot of people don't know that. Because when you ask people, the idea is that Deep Blue was just so computationally powerful the human couldn't compete. It had custom-made hardware, could look 18, 20 ply ahead in the game. And that's all true. That was one of the big advantages was the engineering of the hardware in that system. On the Watson project, I worked with someone who had contributed to the system, and his name is Jerry Tesoro, and he is humanity's worst nightmare. He has made the best backgammon player in the world. He made the best chess player, contributed to the best chess player in the world, Deep Blue. Contributed to Watson. He was responsible for Watson's daily double betting, and is now currently considered an expert on the game of Jeopardy. Occasionally does consulting. And now I hear he's working on Go. And what he did was, they had this great search algorithm to look many moves ahead in the game. The problem was you can't get to the end of a game. So when you can't get to the end of a game, you go really far ahead, and then you have to evaluate the board wherever you are. So maybe you count up how many pieces you have versus how many pieces they have. Well, it's not just pieces, right? It's where they are that matters. So maybe you talk to some chess players, and they tell you, well, board position's important, and all of these things. How exposed is your king, like these kind of things. So maybe you encode those. It's not what Jerry did. What Jerry did was he trained neural nets on human training data. So he would get humans. He actually worked with a chess grandmaster, Joel, I forgot his name, and Jerry would show him two boards and say, which board's better? And Joel would pick that one. No, I like that one. I like that one. And he would do this, hundreds of times, which takes a long time when you're doing chess. And then Jerry would take all these judgments or this training data, and he would bring it in, and he trained his neural net on it. And it was a differential neural net, which would learn how to prefer one of those boards over the other. How would it do that? It would use features from the board. Where are the pieces, how many pieces, and so forth. And so, in the notorious incident where Kasparov accused IBM of cheating, when Kasparov thought that the move seemed a little too human, they went back to the game afterward, and they looked, and it was Jerry's component that had kicked in. So the neural net had fired,